Have you ever stopped to wonder how your code actually does anything? Well, today, we're going to pop open the foundational toolbox that every single programmer uses. We're talking about operators in Python, these simple, almost secret symbols that give your code all of its power. I mean, to you and me, that's totally obvious, right? But think about it for a second. How does a machine, just a bunch of circuits and wires, actually know that? It's not magic, I promise. The answer is in a special set of tools that lets it compare, calculate, and ultimately make decisions. So, let's build our programming toolbox together. First up, we'll get a handle on what these tools even are. Then, we'll stock our box with tools for doing math, some for asking questions, and even some really cool ones for making smart decisions. By the end of this, you'll know exactly what's in your new kit and how to use it. Okay, first things first, what in the world is an operator? It's a really simple idea, but you know what? Understanding this is the bedrock for everything else we're going to build today. So here's the official textbook definition. An operator is just a symbol, like a plus sign or a greater than sign that tells the computer to do something specific. Think of it as the command for what to do with all your data. But honestly, here's a much better way to think about it. If your data, like numbers and text, are your building materials, then operators are your tools. They're the verbs, the action words. They're what lets you actually build stuff with all those materials. Okay, let's grab our first set of tools from the toolbox. These are probably the ones you're most familiar with, the ones we use for any and all calculations. Let's meet the arithmetic operators. And here they are: plus, minus, multiply, and divide. No big surprises here, right? They work in Python exactly like they do in math class. You can think of these as your basic hammer and screwdrivers. They're fundamental, they're reliable, and trust me, you are going to use them absolutely everywhere.
And don't for a second think these are just for homework problems. Every single time you see a price calculated on a shopping site, or a score update in a game you're playing, or even your bank balance changing, it's these simple arithmetic operators doing all of that heavy lifting behind the scenes.
All right, let's move on to the next tray in our toolbox. We've done the math, but now we need to ask questions about the results, and this is where comparison operators come into play. This next set of tools is all about comparison. Now, notice that double equals sign. That's a super important one. In Python, that's how you ask, is this really equal to this? The others, like not equal, greater than, and less than, let your code take two different values and see exactly how they stack up against each other. So what happens when you actually make a comparison? Well, you're asking the computer a simple yes or no question, and the computer doesn't give you a number back, it gives you a straight answer, true or false. So, is the account balance over 100? In this case, yep, true. This simple two-option answer is the absolute foundation of all computer logic.
And why is that simple true or false so incredibly important? Because it's how programs make decisions. Should a door unlock? Is the password correct? Is the player out of lives? Every single one of those decisions starts with a simple comparison. Without these tools, your code would just be stuck on one single track, unable to do anything interesting.
And now for the really clever part. So we've got tools to do math, and we've got tools to ask simple questions. This next set of tools, well, this is what lets us combine those questions to make much, much more sophisticated decisions. Our three main logical tools are AND, OR, and NOT. You can think of AND as being super strict. It demands that both conditions be true. OR is way more flexible. It only needs one of the conditions to be true. And NOT, well, NOT is the easiest of all. It just flips the result, turning a true into a false and a false into a true. Here's a perfect example. Let's say, to get access to something, a system checks two things. First step, is the user logged in? Let's say that's true. Okay, step 2, the system uses AND to also check, is the user a subscriber? That's true as well. Because both are true, the final result is true, and boom, access granted. If even one of those had been false, the whole thing would have failed.
This is how pretty much all modern applications work. It's never just about one simple condition. Things like security checks, search filters, recommendation engines, they all rely on combining multiple checks with these logical operators to create complex, intelligent rules that make everything feel seamless.
So there you have it. Your starter toolbox is officially complete. Let's just do a quick final check to make sure everything is neatly organized and you know exactly what each tool is for. It really just boils down to this. You've got your arithmetic tools for doing all the calculations. You've got your comparison tools for asking those true or false questions, and finally, you have your logical tools for combining those questions to make really smart decisions. With just these three sets, you can build an incredible amount of logic.
At the end of the day, these operators aren't just some abstract symbols on a screen. They are the fundamental tools for solving problems with code. Every app, every website, every single game you've ever used is built on these exact simple ideas. So the only real question left is, now that you have the tools, what are you going to build first?